Our next experiment for our super science make and take is to make an electromagnet using some materials from around your house. Before we go much farther, we should discuss how electromagnets differ from your regular run-of-the-mill magnets, like the ones holding a popsicle stick art to your fridge, or as one of these magnetic toys work. As you know, magnets have two poles, a north pole and a south pole, and attract things made of steel, iron, or some combination thereof, like this nail. Like poles repel and opposites attract. The intersection of romance and physics. For example, if you have bar magnets with their ends marked north and south, one end of the magnet will attract the south end and the other the north end. On the other hand, the north end of the magnet will repel the north end of another magnet. And similarly, the south will repel a south pole. An electromagnet is the same way, except this type of magnet that we're going to make is a temporary magnet. The magnetic field exists only when electric current is flowing. So let's go take a look at something at your house that uses an electromagnet. How many of you have one of these at your house? A doorbell. When you push the button, the doorbell rings. Well, you're pushing the button and completing the circuit, and when you take your finger off, it opens the circuit. Okay? When I say circuit, I mean an electric current running through a coil of wire to create a magnetic field, which causes the little hammer on the doorbell to ring. So today we will be making our own electromagnet. To make your electromagnet, what you're going to need is one long coil of wire, one D-cell battery, one nail with an iron core from your kit, and we're going to be using paper clips to pick up. Okay, so to make your electromagnet, what you're going to do is take your nail and leave some space about as long as your finger hanging from the end, and you're going to wrap the wire around the nail. I'm just going to wrap it a few times right now. Not very many at all. Now, if I take one side of your wire, which you notice is I stripped off the end of it for you to expose the copper. Copper is a conductor. The other part is called an insulator. And if I take the other end of the wire and connect it to the positive side of the battery, I now have an electromagnet. Let's see if it works. I am able to pick up one paper clip. Can I get more? I did. I got 3. Pretty good. And when I let go of the wire on the battery, the paper clips fall off. If you leave it on there a while, they become permanently magnetized. Anyway, the more wraps you have going around the coil, the stronger the magnet will become. So right now I'm going to wrap about half of it. And also, some other things you might want to investigate with your electromagnet is how you put the wraps on. If you make them nice and tight, does that affect how many paper clips you're able to pick up? And did I give you enough paper clips? I'm thinking I probably didn't. Anyway, so this is what my electromagnet looks like. Now you have to watch with this experiment because there's a couple safety precautions. One is the end of the nail. A pencil can be a dangerous weapon. So can a nail. But we're not using it for that. We're using it for an experiment. So just be careful with the end of your nail. And next, your battery. Your battery gets hot because we're creating what's called a short circuit. The electricity runs from the negative side of the battery through the coil of wire, and that magnetizes it, and then back to the other side of the battery. So eventually it will get hot. If your battery begins to get warm, don't keep holding on to it. Instead, disconnect it and let it cool down before you continue. We're also providing you with a number 82 rubber band. What's that for? It's perfectly sized to hold the battery onto your wire. Okay, so let's see how many I can get with all these coils in it. Well, I'd say that's quite a few more, wouldn't you? Have fun experimenting with your electromagnet.